Have you ever been lying in bed and thought, I forgot to turn off that thing, I'll now have to get out of bed, find the remote, find the light switch, and I don't really want to do that. So this was really the trigger to explore how to turn on and off my home air conditioning system, in the bedroom specifically, without getting out of bed. What I want to share with you in this is effectively an expansion on a blog post I did explaining how to use a $16 infrared remote control that connects via Wi-Fi to your home automation system. To do it a lot cheaper than some of the retail solutions, which also go over the internet through Wi-Fi, and maybe not as reliable as a local control system for your infrared devices like air conditioners or TVs. So over on the blog, we start with a scenario which is connecting this trivial problem of not being able to control my air conditioner from my bed to a bigger grid problem that is arising here in Western Australia as we see more solar energy penetrate the grid, producing a lot of electricity in the middle of the day. And the question is, how do we control fleets of hundreds of thousands of devices, including hot water systems, solar inverters, batteries, air conditioners, and pool pumps? How do we control those remotely in a orchestrated way so that we might soak up more energy in the middle of the day, or deal with troughs where we don't want to switch on another conventional power plant later on in the day in the peaks of consumption? Now, sometimes that's referred to as a virtual power plant, where you're controlling hundreds of thousands of devices in a network to effectively act as a huge distributed power plant, typically requiring batteries as one of the big buffers in that system. So to enable that over hundreds of thousands of premises where you're only consuming, say, $1,000 to $2,000 worth of electricity a year, you've got to make that control methodology really cheap. So I thought I'd start right at first principles and at the basics. And this is where we start with step one. Here you'll see a handful of little controllers, which are what we call IR or infrared blasters. And effectively what they are like a TV remote controller, but you control them from a computer or through signals going across your Wi-Fi network. They've got little infrared lights in them, they've got little infrared receiver, and they've got a Wi-Fi communications chip, as well as a power supply that you'll plug into USB. This method of control presents an upside and a downside. The upside being that it will pass the partner test. It's possible to use a regular air conditioning remote control, and this sensor will pick up that you've used that remote, update different statuses on a home automation system, and it means it can work in tandem with the existing method. The downside is that it won't work for devices which don't use infrared. For some ducted air conditioners, for example, they use a radio frequency, or there'll just be a wall panel on the side of the wall with no remote control, and this isn't great for that. My first attempt at using one of these modules was okay to start with. Having done a little bit of research, I was able to connect the device to my Wi-Fi network and get it to talk to the air conditioner through this nifty little app. But unfortunately, my home automation system, Home Assistant, didn't talk very well with it. The previous versions were supported, but this little one wasn't. So I had to move on, and I thought it would be best to also take a learning from this, being that when a sensor goes through a third-party or proprietary cloud service to send its instructions, it's probably not going to be cheap, reliable, or sustainable at scale. So I thought I'd try another path. So when you enter the world of consumer Internet of Things devices, there's one international heavyweight called Tuya. And Tuya white label a lot of their hardware, their circuit boards that connect to Wi-Fi networks. They white label them to other brands that you might have seen in the stores, including ones like Grid Connect at Bunnings. I thought I'd find myself some devices which I could easily reprogram without having to design and build the hardware and the little box to go with it. So I took to the internet and I found three other models. This here was the one that I tried initially that had that cloud portal. But then when I started to look further, I could find just as cheap ones or cheaper ones. You open them up and they look something like this, and if you turn it over, you see that there's a little a Wi-Fi chip. It's called an ESP82, ESP8266, or this particular model is an ESP12F. Now, the good thing about this chip is that I know how to reprogram it, and that's where these steps come together. So let's talk a little less about the theory and get into doing it. So on screen you'll see the blog article, and here I'm going to set up Home Assistant. So lots of great resources on Home Assistant and the sorts of devices that will support it as a server. In this case, there's an Odroid, which is their sort of preferred way to serve you up a fully capable server at the beginning. So we're going to be using ESPHome because it's got a lot of, it's like a plugin to Home Assistant, which allows you to create code that will talk to Home Assistant, auto-discover, and give these sorts of thermostats that you saw on that dashboard over there. So to bring ESPHome on, we're going to Supervisor. In this case, there's a file editor that we'll use later, but okay, we'll go into file editor. You'll need this to effectively set passwords at another point in the process. In this case, I'm referring it in terms of a secrets file, so you don't have to share your passwords over this recording, for example. But once we've got that set up, we'll go back to the supervisor and we'll find ESPHome. So go over to the add-in store, ESPHome. You will see where the stop button is, a install button. In this case, I've installed it, and now I'm going to the interface, the page there. You'll see there are two devices. I'm going to add a third, and this is so we can create a file, a piece of software or firmware that we're going to send to the air conditioning controller. In this case, it's a generic ESP8266 device, and now I'm going to tell it what my Wi-Fi details are, so it can log in. In this case, of course, I'm not super keen on telling you my Wi-Fi details, so I'll show how to update them later on so that they reflect your particular Wi-Fi details, as they'll be different to mine. So this is actually the setup of my second controller. I've already got the first one going, so I'm going to copy the code, and there's a link in the blog to this YAML configuration file, and effectively this sort of code is interpreted by ESPHome to create the real code which goes over to the device. This is sort of a configuration file. So the sorts of things I'm doing here are you'll see Wi-Fi SSID, secret Wi-Fi SSID, and password. That's what there's a sort of secret that sits there in my file editor. So it's just pulling whatever those passwords are in that file. It's pulling those into this code, which will be sent to the remote. Of course, you need to know what pins are connected to different things within this device. So that's where cracking it open helps. You need to follow the wire tracers to tell is the infrared LED connected to GPIO4 or the fourth pin on the microprocessor. If not, then you might need to tweak the numbers that I've used there. It seemed to me that it was quite a common practice across multiple devices. So here I'm going back to my dashboard to grab a particular thermostat, a temperature sensor that I have in the bedroom, and in this case the living room, so that the little widget on my dashboard my home automation dashboard actually shows the current temperature in the room. Of course, the air conditioner won't tell me what the current temperature is. I'll only be able to tell it what I desire the set point to be. So this just sort of cleans up the user interface. So once I'm done, I'm going to compile that. I'm going to take that configuration YAML file, and ESPHome is going to bring in all of the libraries, all the different pieces of low-level code to write some machine code that can be sent over to the controller. So this takes just a little while. We're going to accelerate through this. And when we get to the end, we'll see that green successfully compiled the program. At this point, you'll see it's downloading in the bottom left there, and that .bin file is something that I can now send over to the device. So how are we going to do that? Well, we'll have to connect it to our computer. So here are some instructions to do that. Now, for this particular controller, we had some exposed pins that were nicely labeled. Not all of them do, but that's why I preferred this one. So we can use a little utility called ESPHome Flasher, but that's going to require that we take apart the device. So here's a little unboxing. Here's the manual. There's a Smart Life app that you could have used if you didn't want to connect it to Home Assistant or other devices. This one was sort of glued together, so had to get a screwdriver, crack it open. It took a little bit of doing, but it didn't seem too damaged at the end of the day once I'd done that. So once you've got the cover open, you'll see the ESP12, that blue chip on a custom circuit board. So there are the LEDs on the top and some pins. So let's take it into the bathroom and let's solder it up. In this case, I've got a soldering station with a sort of temperature controller. Do this somewhere which is well ventilated, and in this case, I found a small tipped soldering iron was really handy. So firstly, just going to put some blobs of solder on each of the pins that I'm going to connect up, which is not all of them. And once that's done, we're going to get some of these jumper leads or DuPont cables, as they're super easy to plug into pins on the program, on the controller. So for each one, just hold them to the bead of solder, warm up the solder, and they'll bond down. This can be a nice and quick process then when you've done the blobs of solder on the pads. Those are all soldered on, just checking that they're well connected. In this case, just needed to redo one of them so it was nice and solid before plugging it into the programmer. So there we have it, ready to go. Taking it over to the breadboard now. This is a FTDI chip. I think it's got a CH something chip on there. You need to make sure you've got the right USB driver so that your computer can recognize that. That's a Google search away. Find whatever the chip is, the number is on that black chip on the front, and just do a Google search for the driver for that. In this case, plugging in each of the pins as indicated on the blog page. And you might notice that there's a capacitor, a little cylinder just near that programmer, and or RS232 serial converter, and that capacitor. It sort of stuffed things up a little for me. It's needed for some chips because the ESP32 can have some big spikes of power consumption. The cat. In this case, I needed to remove it. So this is jumping in. In this case, I needed to connect the USB cable, let it power up, and then turn on or reconnect the power cable of the controller. Here we are now going to install the ESPHome Flasher. And once we've opened that up, we can select a USB port, in this case COM6, and I'm navigating to the firmware that I downloaded from ESPHome earlier. At this point, if all goes well, hit flash ESP, and it will send that code over to the device. Once you've got a confirmation that it's all good, you are ready to restart it. So in this case, all I need to do to restart it is to take out the GPIO 0. Now previously that was set to ground so that when the chip was powered up it would go into bootloader mode where it's ready to be reprogrammed. In this case I'm going to take out GPIO 0, just connect it to nothing so it's quote unquote floating, and then power it up again. That means that it powers up as normal, and you'll see that it's just lit up as green on this dashboard. Now I'm just going to go into the logs to see that it's talking okay, that it's communicating okay with this ESPHome platform. And here you'll see that the signal strength is pretty good, it's got its own IP address, it's got a lot of little pieces of information here about what's going on inside that chip. But either way, as long as it's green, we are ready to go. So in this case, I haven't added it to the dashboard yet, so I'm going to go to configurations, integrations, and we'll see now that ESPHome has a discovered tag on it. So I'm going to complete the discovery of this new device. Firstly, it's going to want the password. In this case, I pretty much set the password to be the same as the Wi-Fi password. So I'm just going to grab that. In fact, I go and check what's in my secrets file and copy that off, but I'm going to blank that out for you. Cool. So paste that in, and we're ready to go. We'll tell it which bedroom or which room it is, and that means that it's a bit smarter when it comes to the voice commands later. So now I've got two ESPHome devices, and we'll see that it's automatically been added to the dashboard. I now have two thermostats. Both set to 26, no, so 24, sorry, its current temperature is 26. Now I've just turned it on, now I've just turned it off, and now that's all we need for it to be ready to automate and connect to everything else. So if I go back to the ESPHome page, we're just gonna see if it's received those commands, or if it's responding to things that I'm clicking on this dashboard. So I've just clicked cool. So here we see that the command has come and the device has responded. So let's get this ready to go to where it's going to live. So I'm going to disconnect all of the wires on the breadboard, and now we're going to desolder. I just need to warm those little pads up and pull the wires off. This is why we don't want to use too much solder, because we don't want to pull those pads off the board inadvertently. Let's pop it straight back in its box again. Align it with the USB micro hole in the case. That'll help you know which way around it goes. Just pops back together. Now we're ready to connect it to power. We're going to see whether, once it's in its box and it's just connected to a regular USB power cable, whether it's still talking. But in this case, we're going to go straight downstairs. Works all right. It's going to connect it to this little USB power supply. In you go. And you'll see there's another device which I've got sitting around there. That blue LED will flash, just letting you know that it's connecting. I'm going to put some double-sided tape on the underside here. Nothing too complicated. And we're going to stick that to this cat tree, which has become my little IoT stack. Hold it there for a moment. There it is, all stuck down. No worries. This is the sensor in the context, and what's important is that that has clear line of sight to the air conditioner. The sense check is that if your remote control can be picked up from that place where the sensor is, then the the smart remote control should be able to work from there as well. So now we've got everything connected up. Why did we do this in the first place? Well, we've already seen how we can turn the air conditioner on and off when we check the logs, pressing the on and off buttons on the Home Assistant dashboard, but we can take that mobile. So on screen you'll see that we can use the mobile app and scroll through the dashboard, and just as on the web interface, we can click on, off, we can change the temperature. And you'll hear the little pings as the air conditioner responds to that. Also, in this case, I have a subscription to the cloud services associated with Home Assistant. It's called Nabu Cloud. It's the only paid addition to this, and I have that for other things for Home Assistant anyway. And in this case, I could just straight away start asking things like, okay Google, turn on the bedroom air conditioner, and it would go and do it. So that's pretty much the outcome of this tutorial. We've gone through and we've connected up all of the bits and pieces. We've configured and compiled some code that goes to the ESP12F on the controller that we bought from the internet. And lastly, we're able to control it both through the web interface, the mobile app, as well as the voice control platform. And if you're using Nabu Cloud, you can also do that from outside of your home. So you can say turn on the air conditioner on the way home. So it's nice and cool. The last thing I haven't really covered here is setting up automation rules. One on screen just shows how if the temperature is above a certain threshold at late in the day, the air conditioner will be turned on. So it's nice and cool when you come in and you're able to sleep at night. So that's it, mission completed. Look forward to your comments and happy to answer any of them to help you control your devices, in particular energy intense ones that maybe later in the day you might be able to sell back to your power utility as a demand response device in order to buffer the grid and hopefully get compensated for that at the same time. So till then, see ya.